Assalamualaikum. My name is Affiq Anwar bin Arsad. Okay, I'm student from Mechanical Engineering Department at UNICEL. So today I will present about my final year project, which is Computational Fluid Dynamic Study of Flow Behavior and Pressure in Exhaust Muffler for Cars. This project was conducted by me with supervision from my supervisor, Madam Siti Mahamah binti Rosman. So let's begin. First, I will go through with the problem statement in this study. In this study, there is three main problems that need to be addressed. Okay, note that this problem was occur in current exhaust muffler that I will mention along this presentation. Okay, the first one, the problem that happened is high back pressure that exists in exhaust muffler. Okay, this problem occur in the current design itself, where it create high back pressure in some part of the muffler. Because of this, it also make a second trouble to follow up, which is low flow rate of exhaust gas inside the exhaust muffler, where it affecting the whole fluid, or in this case, exhaust gas flow in the exhaust system itself. Because of these two problems, it's right the third problem, which is burden on the engine, where it need to work more to push back all of those gases away and ensure that it will not flow back to the engine. So for this study alone, I want to solve the first two problems, because if those two problems can be catered, the third problem will follow automatically. Now, let's talk about the objective here. There is four basic objectives here in the study. Okay, the first one is of course to study the airflow of the exhaust muffler. Since I'm going to do project about the airflow itself, so the first step is definitely I need to study about it first. Okay, the second one is I have to analyze the back pressure inside the current exhaust muffler. Since the design is referring to an already in market product, so there is no doubt that this analysis where it should give me a single consistent result. Okay, after that is done, it's compulsory to modify the existing muffler design in order to increase the airflow, lowering the back pressure to increase its performance. Okay, since this study is focusing on performance alone and not the loudness of the exhaust muffler itself, so the redesign will focus on how to make it better performance. To make it through, an analysis on the modified design is taking place. Okay, to make my objective ahead, I need to ensure that the back pressure and the airflow after the modification giving a positive rate compared to the current design one. So in the study, my methodology is divided into two steps, which is designing and simulation analysis. Okay, for me to make it happen, I use help from two software, which is the first software is SolidWorks software that responsible to my CAD designing of the exhaust muffler from its current design until its modification. Okay, the second software I use is ANSYS Fluent, where its job is to run the simulation on the CAD model and make an analysis from it to give me a readable result. So this is the first step in my study, which is I draw the CAD model of current design of exhaust muffler. After designing was done, I'm doing simulation and analysis on the current design of exhaust muffler using ANSYS software. After that part done, I draw the CAD model of modified design of the exhaust muffler. After I'm done with my modification, I'm doing simulation and analysis on the modified design of the exhaust muffler. After all of the method was done, here is the result I got. For the first result, I got the rate of the mass flow rate between both the current design and the modified design. From the table itself, it is shown that the modified design of exhaust muffler had better mass flow rate since it has higher read on the outlet compared to the inlet reading itself. Okay, don't mind that the net value is come from subtracting the inlet value with outlet value, which is modified design is superior because of the outlet flow is higher than the inlet flow, which is it is like a vacuum on the outlet on the modified design compared to the current design, that the inlet flow is still higher than the outlet one. The second result I got from the simulation is the pressure reading inside the exhaust muffler. There is two value here, which is the minimum and the maximum value of pressure reading. So we focus on the maximum value because that is the value of the back pressure itself in the exhaust muffler. So from the table alone, it can be seen that the modified design of the exhaust muffler itself had a lower pressure compared to the current design. Okay, this value shown that even with the modification, a pressure is still exists in the exhaust muffler. However, after a few modification, the value seem to be decreasing, and to me, this alone is quite an achievement in order to increase the performance of the engine itself. This is the illustration being generated by the software itself on the pressure difference on both current design and the modified design of the exhaust muffler. On the other part, I got the velocity of the exhaust gas flow inside the exhaust muffler itself. where it is a bonus result that will strengthen the two results I got before. Okay, from the table, it can be seen that the modified design have a higher maximum velocity, where it proved that the gas flow was increased after the modification. Okay, it also does give a hypothesis that a lower back pressure helps with the gas flow velocity to go through the exhaust muffler. So this is the streamlined flow of the exhaust gas illustration generated by the NC software. So let's discuss here then. Okay, I think it should be discussed that an improvement is an important element in any modification, where in this case is the improvement on the gas mass flow rate and the back pressure created by it. Okay, now the part that should be highlighted here is, since modification is a subjective subject, so do the redesigning. So I think it should be mentioned that trial and error is needed in order to achieve the objective in modification. If the first try is a failure, it should be done again and again and again until the desired result is shown. Okay, lastly, I think I should agree that CFD software helps in simulation analysis, where it saves costs compared to making prototype and run the test inside lab like before. So, what the conclusion here in this study? The conclusion here I got from my modification of the exhaust muffler is three. Okay, number one is the mass flow rate of the exhaust gas increase. Okay, number two is the back pressure exists inside the exhaust muffler is decreased. Okay, number three is the velocity of the exhaust gas through the exhaust muffler had been increased. So with these three conclusions I got from the process of modification of the exhaust muffler design, it can make the engine perform better and reduce the burden on the engine. So this is the end of the presentation. Thank you. So now we go to the part of the Q&A session. So any question about it so far?